Hello, everyone. Today we're going to explore one of the most common but tricky questions in sponge biology. How to identify whether a sponge is asconoid, syconoid, or leuconoid? And we'll do it using a real exam-style question. Here's the scenario. A sponge species is observed with the following features: no radial canals, multiple oscula, flagellated chambers, a greatly reduced spongocoel. A student claims it must be syconoid because radial canals are absent. But is this correct? Let's analyze it carefully. First, let's recall the three basic sponge body plans. 1. Asconoid, the simplest design. Water enters through small pores directly into a large central spongocoel and exits through a single osculum. Notice, no folding, no complex chambers. 2. Syconoid, more advanced. The body wall folds to form radial canals lined with choanocytes, which lead into a central spongocoel. Usually there's a single osculum. 3. Leuconoid, the most complex. The body wall is extensively folded to create multiple flagellated chambers. The spongocoel is greatly reduced, and there are multiple oscula. Water moves through many tiny chambers, making filtration very efficient. Now let's compare the features from our question with each sponge type. Radial canals. Our sponge has none. That rules out syconoid because radial canals are their defining feature. Multiple oscula and reduced spongocoel. These are classic leuconoid traits. Flagellated chambers. Present in both syconoid and leuconoid, but in leuconoid they're numerous and arranged in complex networks. So even though the student thought it's syconoid, the absence of radial canals actually points away from syconoid. What about asconoid? Well, asconoid sponges are very simple. One osculum, large spongocoel, and no folded chambers. Since our sponge has multiple oscula, flagellated chambers, and a reduced spongocoel, it's definitely not asconoid. So what's left? Leuconoid. Multiple oscula allow water to exit efficiently. Reduced spongocoel shows that most filtration happens in chambers, not the central cavity. Flagellated chambers maximize surface area for conocytes, which filter out tiny food particles. This extensive folding and multiple chambers are evolutionary adaptations to increase filtration efficiency, perfect for large or active sponges. Here's a quick table to remember. The sponge in our question perfectly matches leuconoid traits. So the key takeaway: never assume a sponge is syconoid just because radial canals are absent. Look at the overall body plan, including oscula, spongocoel size, and flagellated chambers. That's how you get it right every time. Thanks for watching. I hope this doodle explanation makes sponge body plans crystal clear. Remember, in biology, details matter, but patterns reveal the truth. See you next time.